Intro Algebra Lesson 4-2. We've been spending some time now dealing with coordinate planes and graphing and taking ordered pairs that are x comma y and plugging them onto the graph and looking at them. Now we actually want to look at an equation and see if we can figure out a way to take all the possible solutions that make up that equation and plot them onto a graph. And in doing so, we should produce a nice straight line. If we get anything other than a straight line, a curved line, a bent line, a V, a check, anything like that, then we know we've made a mistake. So we're always striving for a nice straight line. We've made input-output tables. We've taken equations and we've plugged values in for x, and we've done the math and then tried to produce a y value, creating that input-output table. And we're going to take those concepts and put them together here. So the first thing we're going to look for is our steps for graphing a linear equation. Some of these steps you might not actually use. Example, step number 1. It's not always used. Step number 1 says to rewrite in function form. And that's a fancy way of basically saying get the y alone. So if you can play the shuffling game with the equation and move things from one side of the equation to the other using inverse operations until you can get y alone, then you'll have satisfied step 1. But occasionally you'll get an equation that's already y equals. It already has the y alone, and then you won't have to do step 1. So it sort of depends. And we'll take a look at that in more detailed, how we exactly go about that. After you've succeeded in writing it in function form and gotten the y alone, then you're going to choose a few values for x and make an input-output table. So again, this is what we've already been practicing. We're just going to incorporate it together and come up with a completion, a graph. Choose a few values. You get to make up any x values you'd like. Alright? Make up any number you like. I would just suggest don't make them too big. Don't use decimals and fractions unless you have to. Try to keep it as simple as you can for yourself to save time. Once you've completed making your input-output table, those all become coordinates. And those are the coordinates that you then put on the coordinate plane, and when you're done, you connect them with a nice straight line. Again, if you get anything other than a straight line, you know you've made a mistake. So that's the key. Putting them on the coordinate plane, drawing a line through them, and then you should have your line, your equation. It's linear. We want to draw at least 3, and what I suggest is that when you're making your table, pick one number that's positive to put in for x, put one number in that's negative, and then 0. That way you kind of see what the equation is doing on both sides of the positive and negative spectrum. Alright? So let's look more closely at step 1. If we wanted to look at step 1 and rewrite in function form, this basically means this is step number 1, in other words. And we would really like to get y alone. That's the main thing. Get y alone. Again, you won't always have to do this, but sometimes you will. So here's a situation where we could get y alone. Y is here, and it's also being added to negative 5x. What we'd like to get rid of is the negative 5x. So using inverse operations, what's the opposite of negative 5x? The opposite of negative 5x is positive 5x. So we add 5x here, and we have to add 5x over here. And be careful. This does not make 18x. These are not like parts. They will not add together. But because it's addition, you have a choice. You can either stick it after the 13, or you could stick it in front of the 13 because it's addition, and it doesn't matter the order for addition. So y equals 5x plus 13. We have succeeded in writing it in function form because we've got y alone. That's step 1. So if you have to do step 1, that's something similar to what you want to try to do. Another problem like this, we want to get y alone again. This time there's something next to the y, so we'll have to take care of that at some point. But we really want to get rid of this positive 3x. Well, the inverse of a positive 3x is a negative 3x. So we add negative 3x to both sides. Again, what you do to one side, you just do to the other. These cancel out. 4y now equals, because it's addition, you can stick it in front of the 7 or behind the 7. And the last step, now we can separate between the 4 and the y is multiplication. So the opposite of multiplying is to divide. And in doing so, we now have y equals negative 3x plus 7 over 4. Now this is acceptable. It has the y value all alone. There is another form you could choose. You could say y equals, and use the heart-shaped division. So negative 3/4 x plus 7 over 4 Either one of these answers is the same thing. So you can either do negative 3/4 x plus 7/4, which means you have to deal with more fractions, or you could substitute your values in for x here, multiply it by negative 3, add 7, and then divide by 4. They'll both produce the exact same outputs. But again, the key is that we're writing in function form, which means to do whatever we can to get y alone. That's basically what step 1 is telling us to do. Alright? Now let's take a look at the actual graphing process. Use a table of values. Table of values means input-output table. So table of values, that's your in-out table to graph the equation. Now here's the equation. Y equals negative 3x plus 6. If you'll notice, we won't have to do step 1 because it's already in function form. Y is alone. We now make our input-output tables. We like to choose 3. So there's 1 coordinate, 2 coordinates, and a space for 3 coordinates. Make up any number I want. I just like to pick one that's positive, one that's negative, and a 0. So here's negative 2, 0, and 1. Again, they don't have to be huge. I just want to see how the graph is going to be affected. One at a time I plug them in for x, because that's what x equals. Negative 2 times negative 3 makes positive 6. Positive 6 plus this 6 makes positive 12. 0 plugged in for x. Negative 3 times 0 is 0. 0 plus 6 is 6. And 1. Negative 3 times 1 is negative 3. Plus 6 is 3. And what I've succeeded in making are 3 ordered pairs. And these 3 ordered pairs can be graphed on the coordinate plane. Now, the first coordinate is at negative 2, 12. So I start at the origin, I go left 2, and I go up 12. And the next one is at 0, 6, so I don't go anywhere left or right, I just go up 6. And the last one is at 1, 3. So I go to the right one and up 3. Now, I can connect them. And that is my graph. Now let's say someone had chose some other points. Maybe somebody chose negative 1 instead of negative 2. Now if you choose negative 1, negative 3 times negative 1 is positive 3. Positive 3 plus 6 is 9. So once again, I've made a coordinate, and if I go over to the graph, and I go over from the origin 1, I go up 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm right on the graph. Any coordinate that I get from here should be on that purple line. Unless I've made some mistake with my input-output table, it should produce a nice straight line. That's the key. Got to have straight lines. There are 2 other situations I want to look at. Anytime you're looking at an equation that has both the y value and the x value, it's going to be a diagonal line. There's 2 special situations. One special situation is when we only have y. So this means there is no x in the problem at all. An example might look like y equals 5. If you saw y equals 5, there is no x. Automatically, you're going to know that's always going to make a horizontal line. Now it gets confused with the x-axis or the y-axis, and the y-axis is vertical. This is not the y-axis. This is an equation where y equals 5. And what it means is that no matter what x is, y is always 5. Alright? And if we have a special situation for when it's just y, then we have a special situation for when it's just x. And if it's just x, that's going to be a vertical line. An example of it might be x is equal to negative 4. Alright? So if you see this, horizontal. If you see this, vertical. If you see both the letters in the same equation, diagonal. Alright? Taking a look at that one. Here's y equals 5 right here. That means that no matter where x is, I don't care where you are, you're always going to be. What if x was 3? Okay, great. Doesn't matter if it's going to be 3. Y is 5. What if x was 7? Okay, there's x is 7. Y is 5. What if x was 10? Great. Y is 5. What if x was 0? Okay, y is 5. You'll notice it's starting to make a horizontal line because no matter where we go, we always have a y value of 5. So coordinate-wise, this is negative 7, 5. This is 0, 5. This is 3, 5. That's 7, 5. This is 10, 5. You'll notice the x value can change to anything it wants to, but what is y always? Y is always 5. And the very same concept exists for x equals 4. No matter where you are, x is always going to equal 4. Here, here, or here, or here. It won't matter. X is going to equal 4. So looking at the coordinates, this is at the coordinate 4, 9. This is at the coordinate 4, 5. Here's at 4, 0. And here's at 4, negative 5. So what's not changing? The x value is not changing. Y can be anything it wants. And that's what produces the vertical line. So you're either going to get diagonal if you have x and y in the equation, or you're going to get horizontal if just y, or vertical if just x. And that's the key.